In this video, you'll learn how to apply the Enhanced Criteria ranking method. Suppose I was coming to your city to do some risk assessment training, and I said I need a hotel in your town. Can you help me? Please recommend a hotel to me. What would you say in reply? I imagine you might ask what I'm looking for. Suppose I said that my criteria are that I want to be within walking distance to our classes, I'd like access to a nice fitness center, I don't want to spend over $250 per day, and I'd like a restaurant and bar in the hotel. Now you can give me some suggestions, and I could rate the hotels based on my criteria. And if low numbers are considered best, Hotel 4 looks like the best choice for me if all my criteria are equally important. But very few people make decisions as explicitly as this, even though most of us will have some criteria in mind. When you're making decisions for yourself, no one cares how you decide. But when you make decisions for your organization, or for society, or for others, then how you decide does matter. This enhanced criteria ranking technique is often used to identify hazards of potential concern. Some hazards are obvious, while others are not. For example, consider all the spices you find in the supermarket. Which are of greatest health concern, or which have the greatest potential health benefits? To answer questions like these, we need a systematic approach that organizes the scientific information that's out there and available to us. We need to say which of these items are most important and why they're important. This technique enables us to do just that. Consider these two food safety examples. Vibrio cholera in seafood in the city of Hong Kong. Which restaurants present the highest risk potential? Or which seafoods present the highest risk potential? We could be looking at pesticides in fruits and vegetables in Saudi Arabia and ask which foods present the highest potential risk, or which pesticides present the highest potential risk. The uses for a technique like this are endless. There are many other groups of things we might want to rank. We often need to set priorities, and so we can use rankings to do that. We might want to rank pathogens, commodities, pathways, risk management measures, imports to sample, facilities to inspect, and so on and so on. To do this, we need an organized approach that's based on science, that is easy to replicate, and easy to explain to others. Here's a technique I helped a U.S. government agency develop. It's called Enhanced Criteria-Based Ranking, and here are its steps. Criteria, ratings, all possible combinations of ratings, ranking, evaluate the reasonableness of the ranking, add criteria, new combinations of ratings, and a new ranking. Let's see how to use this approach using an example. Risk assessment always begins with a question we're trying to answer. Imagine that risk managers in the U.S. Army Corps of Engineers would like to know the answer to this question. Which lock gates in the United States present the greatest potential risk to health and safety, and therefore should be repaired first? There are many locks and dams in the United States, and so there are many lock gates, far too many to do a quantitative risk assessment on each pair. So we will apply the Enhanced Criteria Ranking Qualitative Risk Assessment tool to this conceptual problem. Risk assessment does not rely on plausible thinking or opinions. It relies on the best available evidence and an intentional effort to address uncertainty. So step 1, criteria, is intended to identify the most relevant evidence needed to answer the risk manager's questions. To identify the criteria, it's wise to remember our simple risk equation, risk equals consequence time probability, and start from there. What are the consequences of most interest to us in answering this question? Criterion 3 defines the consequence. Criteria 1 and 2 help identify the probability that these consequences will occur. In this example, we will assume all these criteria are equally important, but as you will see later, that's not a necessary assumption. It is vitally important to the credibility of your assessment, however, that the criteria reflect the most important aspects possible for assessing the risk. Also, note that you must define specific scenarios for each criterion. These scenarios must be mutually exclusive. That means each lock can match only one scenario. And they have to be collectively exhaustive. This means each lock must align with one of your scenarios. Here we've defined the risk potential associated with each scenario as high, medium, or low, as defined in the slide. So age, high risk potential would be 20 years old or more. A medium risk potential would be 10 to 20 years of age, and a low risk potential would be under 10 years of age. Likewise, you see the scenarios for the other two criteria. This method will not work unless you can measure each criterion for each item. Lock gates in this example. Each of these three criteria can be measured either objectively or subjectively based on evidence. If a criterion does not allow you to discriminate among the risk potential of the locks, in other words, if all lock gates receive the same rating, it would not be a well-chosen criterion. You would, in this case, note that you considered that criterion, but because it did not discriminate, it doesn't appear in your final risk assessment. Ordinarily, you would just use 3 or 4 evidence-based criteria with a method like this. If you need many more criteria or scenarios, then you might need a more sophisticated method to assess your risks. Now that you have your criteria and scenarios, step 2 is to gather your data and evidence and rate each lock for each of the criteria. This process must be documented. This can be done simply in this case by noting the age and frequency of use of the lock and carefully describing the potential consequences of failure, taking care to cite the source of the information used to make these measurements and judgments. When uncertainty is present, rating will sometimes require using expert judgment to critically evaluate the available information. The assessors develop estimates for each lock gate, hazard, or item to be ranked against each criterion. Here we use letters as ratings because they do not represent an absolute measurement of risk, but only a relative means for comparison. Letters also tend to prevent readers from trying to do math with numbers that do not possess normal numerical qualities. The third step is basically where you handle the weights applied to your criteria. You do this by creating a list of all possible combinations or ratings. Then you group them into like priorities. In this example, where all criteria are equally important, you see the groupings. The greatest risk potential is clearly high, 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 shown at the top of the list. The least risk potential is clearly low, low, low. All other combinations must be identified as well. In this case, if you let an H equals 3, M equal 2, and L equal 1, and add the values, you obtain the groupings you see here, from 9 at the highest risk to 8, 7s, all the ways to get a 6, a 5, a 4, and ending with a 3, the lowest potential risk. The same step is repeated here for a situation where we might have unequally weighted criteria, just to demonstrate how this could be done. For this slide, I have assumed criterion 1 is twice as important as any other criteria. This assumption yields a different set of rankings than you saw on the last slide. For the remainder of this exercise, we'll revert to the equal weight assumption. In step 4, you use the list you just created to rank the items from greatest risk potential to least. Notice here that Steadley had a rating of HMM. Of all the lock gates listed, this was the greatest risk potential, by definition. Can't Get had a rating of LLL. That is the absolute least risk, but it also happens to be the least risky from this group. Everything else fell into a mid-range where we really couldn't discern too much difference here. It's the risk manager's judgment that draws the line to identify those locks of greatest concern or to create other subjective clusters of risks. Step 5 often confuses people. When we created this methodology, we knew it was not the most rigorous risk assessment possible, and it could be subject to user errors. So we added the spot check step and called it Add Criteria. After the initial ranking is established, you should look at it. Does it make sense, or is something wrong with the ranking? Have you thought properly about the issue? Have you identified the best criteria? Have you neglected an important criterion? In this example, suppose we're surprised that Jack Flash did not come up at the top of the list. Imagine that it's common knowledge that those gates are in the greatest need of repair. If that's the case, this might make us think that perhaps we didn't consider all the most relevant criteria. And then, in such a case, a new criterion might be added to more accurately reflect the assessor's rationale for the ranking. This is not a step inserted to allow you to change the model to get the answer you want. It's a step that enables you to review and improve the model if necessary before finalizing the rankings. In this example, imagine that we have decided something is missing. We did not consider that if Jack Flash did fail emergently, the consequences to the flow of navigation and power production would be huge. These consequences were not considered in our original consequence criterion. So we might add a fourth criterion, such as you see here, the cost of emergency repair. If there could be major disruptions to navigation or power and much higher cost to repair, we're going to call that high risk potential. If there would simply be much higher cost to repair without those major disruptions, we'll call that medium risk potential. And if the emergency repair would be the same as a scheduled repair, we're going to call that low risk potential. Step 6 is a repeat of step 2. However, now you must rate each lock gate for the new criterion. Notice that Jack Flash received a high risk potential for criterion number 4. And now the new combined rating for Jack Flash is MHLH. Just a hair worse than the Steadley lock gates. To complete step 7, the new rankings, you'll need to redo your list of all possible combinations and to draw new subjective clusters of relative risks, as you see here in this slide. Now the cluster of greatest risk includes 3 locks. There still are 4 locks in the moderate risk group, and only 1 lock remains in the least risk. With the new criterion, Jack Flash has at least been separated from the pack of moderate risk lock gates, and the assessment rings more true. So this hypothetical example gives you an idea of how to use the Enhanced Criteria ranking technique. If you have questions, please be sure to ask them in class.